This is exercise 1.08, dot plots and stem and leaf plots. Okay, here we've got a dot plot. We can see the numbers, the scores on the horizontal axis, evenly spaced apart, and then the dots, and they look like columns, okay? And here is a stem and leaf plot. We've got the stem here and the leaf. So, for example, that's 79, 75, 78. However, this stem and leaf plot is actually out of order, and it's actually not really meant to be like that. So over here we should have the 1 first, then the 5, then the 6, 8, and the 2, 9. So this stem and leaf plot here is unordered. It does need to be ordered though, okay? So dot plot, it's a simple type of column graph, okay? It uses a dot, cross, or symbol to display each score, so we could count how many scores there are. So number 1 occurs 3 times, number 2 occurs 6 times, etc. And it's also called a line plot. In the stem and leaf plot, the actual scores are listed. They're usually in order, however these ones aren't. The stems show your first digit and the leaf shows the last digits, and it's also called just a stem plot. Now, dot plots and stem and leaf plots are great for quantitative data. So not categorical, quantitative data. We need numbers. We put numbers into a dot plot and a stem and leaf plot. It's good for small sets of data. It's good to show gaps and clusters. So for example here, we can see that it's clustered around here, that there's a gap here, that this is an outlier, okay? So it shows gaps and clusters. It also shows outliers. In other words, outliers are scores that are very different to the rest of the scores, okay? So that's what it's useful for. See here in our stem and leaf plot, we can see a lot of the scores are clustered around the 80s, you know, I suppose high 70s and 80s and 90s, okay? Strengths of both of these graphs, that they are easy to read and draw. They show differences and patterns very clearly. This is like a sideway column graph, I suppose, a stem and leaf plot. And it shows the spread of scores fairly well. And the stem and leaf plot shows you the actual scores as well. You can look at each score, okay? Weakness is if you've got large sets of data, it is difficult to display, and that's when you'd use your frequency histogram or polygon for large sets of data, okay? All right, just looking at a few questions from the exercise. So the first exercise here, exercise 108, sorry, first question in the exercise. It says a class was surveyed to find out how many hours each student spent on maths homework each week, and the results are shown there, and we have to draw a dot plot. So before you draw your dot plot, we need to look at the highest score and the lowest score. So here's a child that did no homework, and here is a child that did 18, and this one looks like an outlier. So we're going to have to be able to draw a graph, a dot plot, that goes up to 18 centimeters, or 18, sorry, 18 scores, and we're going to have 0 as a score as well. So we'll just draw this graph up. So you actually put your little things underneath. So I'm putting my little, so every centimeter, using your ruler, you must evenly space out all your scores. So notice I'm using a ruler, drawing a horizontal line, putting little dashes for all of these scores, where they're going to go, okay? And we start with 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Okay, and now you can just put your scores on there. Okay, so the thing is, I just hope I've left enough room here. We've got, if we just look here, we've got 7, 6, 8, 9, 5. We've got 10. We've got another 6. We've got 2 9s again. We've got 0, 9, and 8. So we've got a 0, we've got a 9, and we've got an 8. Now what you've got to do is make sure that your first line of dots are all straight and your second line of dots, etc. Then we're up to the second row of scores. We've got 18. And then we've got 7, 5, 3, 4. So we've got 7, 5, 3, 4. We've got 9, 6, 7, 8. So we've got 9, 6, 7, 8. We've got 10, 7, and 8. So 10, 7, and 8. I think this other dot up here should have been just a bit higher. Okay. So these are meant to be evenly spaced. This dot here, I think I drew it a bit too close. But notice that the dots are all in line. Those 3 dots, those 4 dots are in line. They're all in line. And all these dots here are in line. Well, they're meant to be in line. Okay. So, all right. So it sort of looks like a bit of a column graph. They look like columns. Okay. So draw a dot plot. That's done. How many students are in the class? You can just count the dots, or you can count the students here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 2 is 24. You might want to make sure also that you've got 24 dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 23, 24. And that's fine. And it says, what are the outliers? Well, obviously, the outlier is 18. And the other outlier is 0. So the outliers are 0 and 18. And the reason that they're outliers, they are quite different to the other scores. Okay. Okay, maybe this child up here, it says, so they're the outliers, 0 and 18. I don't know, either this kid's very lazy and this one's very studious, not sure, or this child does extra homework, okay? And D, it says, what are the clusters? What are the clusters or gaps? So the scores are clustered. So it looks like a lot of the scores are around here between 6 and 9. From 6 to 9. Okay, so the scores are clustered from 6 to 9. I know we've got these two here at 5 and 10, but they seem to be mostly, you know, it's like these have got the highest frequencies, okay? And the gaps are at 1 to 2 and from 11 to 17, okay? All right, that's question 1. So that's just a really simple question, okay? Okay, another dot plot question. This dot plot shows the scores out of 10 of students competing in a spelling bee. So how many students competed in the spelling bee? Remember that each dot represents a person. Look, you can just attempt this question and then you can turn on the video later and just check your answers, okay? So the number of students, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 2, 3, 4, 5, 6, 7, 8, 9, 30 students, okay? So there are 30 students that attempted there. I mean, there's another way you can do it. You can sort of look at these here and say you've got 1, 2, 3, 4, 5. Just up to there, if I just cover that with my ruler, you've got 15. Then you've got another 4, that's 19, 20, 21, 22, 23, 24, 5, 26, 27, 28, 29, 30. Or you might want to count it twice, make sure you don't make a mistake. So we've got 30 students. What percentage scored more than 8? So more than 8 does not include 8. So it's the percentage that got 9 or 10. So we've got 1, 2, 3, 4, 5, 6, 7. Now that's 7 there and 1 more. So it's 7, and this is 1 higher, so it's 7 and 8. So it's 15 out of 30. Now, we know that that's a half. That's not a percentage yet. That's a fraction. So if you times that by 100, you will be able to change it to a percentage. 15 over 30 is a half. So a half of 100% is 50%. So 50% of students scored more than 8. Where are the scores clustered? The scores seem to be clustered around, so clustered from about 6 to 10, okay? D, comment on the general performance of the contestants in the spelling bee. So, well, you could say that more than half got, well, way more than half. We've got 27 out of 30, for example, that got more than 6 or more correct, you could say, so when you look at it like this, you can see that only 3 scored less than 6 out of 10, okay? Most of the students performed fairly well, which is 6 or more out of 10, okay? And you could even say, oh well, even you could even say that 50% scored 9 or 10. Okay, so yeah, all right. So that just shows quite well that that the students did well. Okay, in a dot plot, you can see the trend quite easily. Okay, question 7. This is a stem and leaf plot. So Jeremy sells sausages outside the hardware store on Sundays. The number of sausage sandwiches. The number of sandwiches sold each day over 30 Sundays was recorded. So draw a stem and leaf plot to represent this data. The lowest score, it does appear to be 47. Oh no, 28. 28 seems to be the lowest score. And 117, I think, is the highest. So we've got the 20s, 30s, 40s, 50s, 60s, 70s, 80s, 90s, 100s, and the 110s. So this is like the 10s, but here we have to put 10. That's 100 and something. Okay, so we have to try and get these in order, unfortunately. So I might just put them over here, but then we have to order them here. So we've got 66. So I'm just going to put that here, and then we've got 64 and 28, 93, because I have to order it, 47, 110. Oops, so that's 110, so it goes here. 53, 68, 117, 117, and 43. And we've got 72 and 68, and then 84, 103, so that's 103, 59 and 82 and 78 and 61, 104 and 79 and 51 and 63, so we've got 51 and 63, 112 and 81, 79 and 94, 42 and 57, 83 and 100. Okay, so now I'm going to order those. So 28, there are no 30, so we don't put a 0, we just don't put anything there. Then we've got 237, that's the order here, 237. Then the order here is 1379. Now notice I'm trying to put all these first digits under each other, then the second digits all under each other, etc. Then I've got 134 and I've got 688. And I've got 2899, they just happen to be in order. And we've got 1, 2, 3, 4. And then I've got 3, 4. Then I've got 0, 3, 4. And I've got 0, 2, 7. Okay, so that, I just write here that that's my stem and this is my leaf. So that is the ordered, so that is a stem and leaf plot. Okay, and it's ordered. I just put these over here, the bits of the leaf, so that I could then order that. Now I don't really need this anymore. Okay, and just checking that we've got 30 bits of data. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 30. Maybe you don't count those because that reads as 28, 42, 43, 47, etc. It says, on what percentage of days did Jeremy sell more than 50 sandwiches? So more than 50 would be all of these scores. So we know that there's 30 altogether. So there's basically 1, 2, 3, 4 that aren't included. So part B, it's 26 out of 50. And to change that to a percent, 26 out of 30, sorry. times 100. Okay, so just getting your calculator out for that. So we get 86.666, etc. Even though the last digit on your calculator is a 7, this is 86.6 recurring percent. You can either write it like that, or you write it as 86 2/3%, because remember, 0.6 recurring is 2/3, okay? And part C, what is the outlier? And give a possible reason. Well, 28 is the outlier. And what's the reason? Jeremy sells sausage sandwiches. Maybe it was a reason for this. Maybe it was bad weather. There was bad weather on that day, so less customers. Okay. All right, that's the end of question 7. Now, question 11 on the last page. At the school athletics carnival, runners recorded the following times in seconds for the 100-metre sprint. So the times, the shortest time seems to be 11.8. Oh no, 11.6. But there are no 10 point something. And the highest, the longest, biggest, oh no, 18.7, I think is the longest time. So in our STEM, it starts from 11, and we've got 12, 13, 14, 15, 16, 17, and 18, and our leaf. Okay, so we don't put the decimal points in our leaf. What we do, we're going to write this as a, I suppose, a legend, and we're going to show that, for example, let's look at our first score, 12.1. 12.1 is like this, 12/1. Okay, so 12.1, we just put the 1 here, but we have a little legend over there, and it says like 12.1 is represented with a stem of 12 and a leaf of 1. Okay, so again, look, I'll try and get all the 11s first rather than putting all the scores here on the side. Now we've got 11.6 and 11.8, so I'll just do those two first. I'll just go in order, 6 and 8, and then I'll try my 12s. I've got a 12.0, then we've got a 12.1. I'm just looking for some other 12s. They're the only ones I can see so far. So 13, oh no, here's a 12.4. Okay, hopefully there aren't any more. Okay, then we've got some, just got to be careful this way. If you circle them or cross them off, then you can fix up something if you've made an error, I suppose. In our 13s, we've got 13.6 there, and I can't really see any others, so 13.6. Then in our 14s, we seem to have a few of those. That looks like it's the lowest, 14.3, and then we've got a 14.5 here. And then we've got a few 14.6s. That was 3 of those, 3 14.6s. I've just seen a 13.9 there, which I missed out before. Okay, so 15s, it looks like there's a 15.4. Then we've got 2 15.6s and a 15.7. And 16s, it looks like there's 16.3 and 16.5 and 16.8. Oh, sorry, you can't see those. And 17s, we've got 17.2, 17.4 and 17.7. So 17.2, 17.4, 17.7. And in the 18s, we've got 18.1 and 18.7. Looks like everything's circled. 18.1 and 7. Now we just have to see how many scores we've got. We've got 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 is 24. Making sure we've got 24 scores here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. It all looks fine. So we've represented the data in a stem and leaf plot using stems of 11 and 12, etc. How many runners were there? Well, there are 24. We just counted them. What was the best time recorded? That would be the lowest time, 11.6. So you see that to look for the lowest time here, you might miss it. Whereas when it's in a stem and leaf plot, you can easily see the best time is 11.6. That was in seconds, so you should put your units. And the worst time recorded would be the longest time, which is 18.7 seconds. Again, being in a stem and leaf plot, it's really easy to see that that is the longest time or the worst time recorded. And it says what percentage of students took more than 15 seconds. So more than 15 would include 15.4, 15.6, etc. So it's from here down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 students out of the 24 times 100%. Now remember, 12 out of 24, that's half of them. So it's a half of 100%, which is 50%, took more than 15 seconds. Actually, we should write it as 50.0 seconds because they want it to 1 decimal place. So well, we probably don't need to really, but 50.0, I'm not going to fix that now. And, well, so it's 50.0 to 1 decimal place, 50.0. 1 dp. And the last question, it says to qualify for the regional carnival, a runner's time must be less than 13.5 seconds. And what fraction of students qualified for the regional? So the number of students with less than 13.5. Well, none of these are less. They're greater than, so it's just these 5 students. 1, 2, 3, 4, 5. We've got 5 students out of 24 because there were 24 schools altogether. So, and that's it. All right, that's the end of this video on stem and leaf plots. Oh, sorry, and dot plots as well.